chapter 6.3. Today we're going to tackle the double angle identities. These are identity numbers 35, 36, 37. And basically we're going to do the same thing we did with the sum and difference formulas. We're going to write things as single trigonometric functions. We're going to be given a sine, cosine, or tangent value, and then we're going to be asked to find sine and cosine and tangent of 2 theta or whatever. So it's some of the same types of things that we've done in the other chapters, just with new identities. What I'm looking for when I try to write something as a single trigonometric function is a structure that matches something that's on my sheet. So if you take a look at number 35, I believe it is. Make sure my sheet says, yeah, 35. 35 says this: sine of 2x is equal to 2 sine of x cosine of x. Alright, the structure I'm trying to get you to recognize here is that sine times cosine of the same angle exists in this. It doesn't matter about the 2. What matters is the fact that sine and cosine are being multiplied together, which matches sine and cosine of the same angle right here being multiplied together. Obviously that's not a 2 in front, there's a 4 in front. Alright, I can make that number anything I want it to be, and I can still use this identity because the sine and cosine match this. Alright, so let me show you what I mean by that. So if I take that expression they gave me and I write it like this: 2 times 2 sine of 5 theta cosine of 5 theta. This part here matches the exact structure of that part there, which tells me that to get to this point, I'm going to take whatever this angle measure is and I'm going to double it with a sine. Alright, so this part that I've got boxed off here is going to be sine, and I'm going to double 5 theta, so it's going to be 10 theta. The 2 that's out here that's being multiplied by this box is still outside of here, so 2 times sine of 10 theta. Let's just, for the sake of argument, suppose they told me this problem. Suppose they gave me sine of 3x, cosine of 3x. Same issue. They want us to write that as a single trigonometric function. That doesn't have any number in front of it, right? If I go ahead and make it 2, because I want that 2 there, because it has to have the 2, that's what the property says. I want the 2 there, but I got to keep this 1 times that, right? Half of 2 is 1. So again, you're just going to put a number out in front to allow that to happen. This is going to be sine of 6x, because again, it's got the proper structure for sine of a double angle. We're supposed to double whatever this is to get the angle measure, and then there's a half in front of it. So even if you don't get the number you want there, you're able to put a 2 there, and you just need to multiply by whatever else is necessary to make what the original problem stated, which was 1, not 0.1. Touch the board. Alright, so that's the idea there. And again, you got your 3 properties. You got cosine of 2x has cosine of 2x has 3 possibilities. There's cosine squared of x minus sine squared of x, 2 cosine squared of x minus 1, and 1 minus 2 sine squared of x. So again, if you get any one of those structures, it doesn't matter what the angle measure is. If it says cosine squared of 55x minus sine squared of 55x, that's just going to be cosine of 110x. So again, whatever this is, you're doubling it over here. Tangent of 2x, the property says 2 tangent of x on top over 1 minus tangent squared of x on the bottom. Again, if it has that structure to begin with, that's a tangent structure. Whatever the angle measure is, you double it, and you have the ability. So again, that all the problems involving this are going to have one of these structures, or the number 35 structure. You recognize that it's cosine or tangent or sine, and then you double whatever the angle measure that you're dealing with in the problem to do that.